All right, we've made it to day 30 of Let's Learn Real Analysis on TikTok. Thank you all for all the comments and questions. Today we're going to keep talking about infinite series. Now my students have seen a ton of infinite series when they took Calculus 2, and so I'm going to do a very brief treatment in the class this semester. But I do want to talk about some important infinite series and how we can use them. I mentioned one in the last video when we talked about e to the x being this formula up here. And the way that we would prove that is using something called the ratio test, which is actually a beautiful fact to prove. Probably not right for TikTok. Another really important infinite series is something called the geometric series, where we have a starting term, and then at each step, we multiply that by some fixed number r, and we add all those things up. Pause the video if you want to read more about this, but basically, whether or not these things converge is all dependent on whether that factor that we're multiplying things by is bigger than 1 or less than 1 in absolute value. And it's really awesome that we can add infinitely many numbers together and have that sum be some finite number. I always think about pizza because I never wanted to finish all the pizza in my fridge, and so I would always eat half of what was left. So I'd eat maybe half a pizza, and then a quarter of a pizza, and then an eighth of a pizza. And at the end, of course, I was getting very, very close to a whole pizza. Now, obviously, there are lots of infinite sums that are going to diverge. For instance, 1 plus 1 plus 1 plus 1 plus 1. That's obviously going to infinity. But perhaps more interestingly, this series up here at the top, where we add the reciprocals of all the natural numbers, that actually diverges as well. And I'm going to give my own version of this proof in a second, but I will let you pause the video here after I get out of the way, just because this is the original proof, according to Wikipedia, that comes from the 14th century. I did not know that until I made this video. Okay, the proof that I'm going to give is basically the same, but I'm going to translate it so that it's more base 10 rather than base 2. And so we have to add up all the reciprocals of all the natural numbers. And I want you to just think about the first 10 numbers. And actually get rid of the first 5. Just think about the fractions 1/6, 1/7, 1/8, 1/9, 1/10. Those are all at least 1/10. They're at least 1 dime if you have American money. And so the sum of these is definitely at least 50 cents or half a dollar. Okay, let's do the same thing. Let's look at all the numbers 1 to 100. Get rid of the first 50, and let's look at the fractions 1 over 51 all the way through 1 over 100. All of those are at least 1 penny, or at least 1 over 100. And so those 50 things are going to add up to another 50 cents, or another half a dollar. We can do the same thing, and we can see that terms 501 to 1000 are going to add up to at least another 1/2. And now when we think about that whole infinite sum, because there's no overlap of these terms, right? 6 through 10 doesn't overlap with 51 through 100 or 501 to 1000. We're going to get 1/2, just eventually we're going to always get another 50 cents. And just adding those things is going to get as large as we like. And so that shows that the original harmonic series is going to go off to infinity.